Hello students and good afternoon. So today we are doing this chapter, that is integration by parts. So in the last online class also we were doing the same topic, integration by parts. So today is the continuation class of this chapter. Same exercise 7, page number 381, 5 marks section from book Higher Mathematics for Class 12 by SN Day. So let us integrate this question number 23. So this is integration of sine inverse within root x upon a plus x dx. Let us evaluate this integration. So this question is very important. You can mark it because this question is from HS question paper. Okay. So actually I don't know the exact year in which year this problem was given, but this problem is from HS question paper, right? So this question is very important. So therefore I is equal to integration of sine inverse root over x upon a plus x dx. Okay. Now in this case you cannot directly integrate it. You can use directly integration by parts. This is also the integration of only one function, that is inverse circular function, then dx. So I already told you that whenever you have integration of only one inverse circular function, then also you have to use integration by parts. But in this case, don't use integration by parts directly. So in this case, you have to do the method of substitution, that is trigonometric substitution method. Okay. Now within square root x upon a plus x is there. What should you put for x? Always you have to, in this case, you have to consider the denominator, that is a plus x is there in the denominator. So what should you put for x so that we can use the formula? So if there is a plus x, then we can put x is equal to a tan square theta. Okay, you can put x is equal to a tan square theta. So if you put x is equal to a tan square theta, then this integration will be quite easier. Okay, so you may have this problem also, that is integration of, instead of sine inverse you may have cos inverse root over x upon a plus x dx. So you can do it at home. So this is your homework. So instead of sine inverse there is cos inverse. So if you have integration of cos inverse within root x upon a plus x dx, how will you integrate it? What will be the trigonometric substitution method in this case? But in this case we cannot put x is equal to a tan square theta here. Okay, so in this case you can put x is equal to a cot square theta. So this is your homework. Okay, so these two problems are of similar type. So let's do this question number 23 here. You can do it at home. Okay, so that is your homework. That is also very important. So in this case we put, let x is equal to a tan square theta. So what will you do now here? Let us differentiate both the sides with respect to theta. So let us write here differentiating both the sides with respect to theta. Therefore dx by d theta is equal to a into tan square theta, x square form, 2x, that is 2 tan theta. Again you have to differentiate the term which is assumed as x or theta. So what is the differentiation of tan theta with respect to theta? It is sec square theta. So now you can do cross multiplication. Dx is equal to 2 is written first, 2a tan theta, this is sec square theta d theta. So this is the value for dx. Is that clear? So now let us put these values in I. So therefore I is equal to integration of, this is sine inverse within square root, what is x here? It is a tan square theta divided by a plus a tan square theta, right, into, what is the value for dx? It is 2a tan theta sec square theta d theta. I hope you have understood it. Okay. So in this case, this 2a is constant. It is taken outside integral sign. So I is equal to 2a integration of sine inverse. So within square root we have, let us simplify the expression within square root. A plus a tan square theta. So here a is common, isn't it? So within bracket we have 1 plus tan square theta. A will be cancelled. So you will have, this is tan square theta divided by, what is 1 plus tan square theta? Sec square theta. What happens to a? They are cancelled. Then into what do we write? Outside square root we write tan theta sec square theta d theta. Is that clear now? So let us simplify it again. Or I is equal to, this is 2a integration of sine inverse, what is square root? This is tan theta divided by sec theta into, now this is tan theta sec square theta d theta. Is that clear? So now let us simplify it. Or I is equal to 2a integration of, this is your sine inverse within bracket. What is tan theta by sec theta? You can convert it to sine theta by cos theta upon, what is sec theta? What is sec theta here? 1 by cos theta. Bracket closed. Then you can write tan theta sec square theta d theta. Tan theta sec square theta d theta, right? So, or I is equal to, this is your 2a integration of this cos theta gets cancels. So this is your sine inverse within bracket sine theta. Then we can write tan theta sec square theta d theta. Okay. Or I is equal to, this is twice a integration of, what is sine inverse sine theta? Theta into tan theta into sec square theta d theta. So I think you have understood it. So we have got this expression, simplified expression. Okay. Now we can use integration by parts. So what can we take this theta as? Theta is algebraic function, right? That is your a. And tan theta sec square theta d theta, that is tan theta sec square theta is trigonometric function, that is t. So a and t is there. So which letter comes first among these two letters a and t in the word liet or islet? A, algebraic function, a comes first. That is, theta is the first function and tan theta sec square theta is the second function. So I think you have already done in the previous problem, this type of problem, you have done it. Okay. So now let us use integration by parts, and here there is 2a. And within third bracket use by parts, theta is the first function taken outside, integration of tan theta sec square theta d theta minus integration of second bracket, this is d by d theta of theta, integration of, this is tan theta sec square theta d theta, second bracket closed, then what do we write? D theta. Okay. Then again third bracket is closed. But you have to evaluate this integration. Integration of tan theta sec square theta d theta. There is also integration of tan theta sec square theta d theta. But you cannot evaluate it directly. So let us take it outside. Okay. Let us take it as I1. So this is I1 is equal to integration of tan theta sec square theta d theta. Okay. So how can you evaluate this integration? You know that the differentiation of tan theta is sec square theta. We can use the method of substitution in this case. So let z is equal to tan theta. So let us differentiate both the sides with respect to theta. Differentiating both the sides with respect to theta. Therefore, this is dz by d theta is equal to sec square theta. Now let us cross multiply it. Dz is equal to sec square theta d theta. Understood? So next, what does I1 become now? So I1 is equal to integration of What is tan theta? It is z. What is sec square theta d theta? That is your dz. Or I1 is equal to, this is your z square by 2. You know this integration, right? That is z square by 2 plus c, right? So next, therefore I1 is equal to, now we can put the value for z square. What is z? Tan theta. So it is tan square theta by 2. This is tan square theta by 2 plus c. Understood now? So this is the value for I1. So let us put this value for I1 in this I, right? So therefore, what is I here? Outside third bracket there is 2a not integration. 2a third bracket is open, then theta is kept as it is. Then what is integration of tan theta sec square theta d theta? It is tan square theta by 2. Don't write c here, you will get confused. Okay, so whenever we did the previous problem, in that case we have directly integrated that that can be integrated function. We have directly integrated that function, but we don't write c out there, isn't it? Is that clear? So minus integration of what is d by d theta of theta? That is 1. What is you don't have to write it 1. What is integration of tan theta sec square theta d theta? That is tan square theta by 2. Tan square theta divided by 2. Don't write c there. Okay, again d theta is there. Then third bracket is closed. So I think you have understood it. Or what is the value for I now? In the next step, let us multiply it by 2a. So 2 gets cancelled. A theta tan square theta, then minus, right? Again you multiply this integration by 2a. 2 gets cancelled. A is constant, it is taken outside. Integration of tan square theta d theta. So I hope you have understood it. Now how can you evaluate this integration? Integration of tan square theta. You cannot evaluate it directly, right? So you know the integration of sec square theta d theta. So let us convert this tan square theta in terms of sec square theta. So what is the formula for tan square theta in terms of sec square theta? It is sec square theta minus 1. You know sec square theta is equal to 1 plus tan square theta. So what is tan square theta is equal to sec square theta minus 1. So or I is equal to a theta tan square theta minus a integration of, this is your within bracket, you write sec square theta minus 1 bracket close, then d theta. Okay, or I is equal to a theta tan square theta, let us separate the term, minus a integration of sec square theta d theta minus 2 minus plus a integration of d theta. Clear? Now next, or I is equal to a theta tan square theta minus a, what is integration of sec square theta? Differentiation of which function is sec square theta? That is your tan theta, right? That is your tan theta plus a theta plus c. Integration of d theta is theta. So I think you have understood it, but this is not your answer. You cannot leave the answer in terms of theta, but you have to get the answer in terms of x. Okay, now from here you have to get the value for theta. What is tan square theta? Here tan square theta is equal to x upon a, right? Next, what is tan theta? So tan theta is equal to root over x by a, right? Tan theta is equal to root over x by a, or from here, what is the value for theta? That is tan inverse root over x upon a. That is your, this is tan inverse root over x upon a. First of all, you have to get the value for tan square theta, which is equal to x upon a. Then you have to get the value for tan theta only, root over x by a. And what is the value for theta? Tan is taken to the left hand side or right hand side, and it becomes tan inverse root over x by a. So I think you have understood it. So let us put it here. Or I is equal to a, what is theta? What is theta? Tan inverse root over x by a. tan inverse root over x by a into, what is tan square theta? X by a. You can write x by a. Tan square theta is x by a minus a into, what is tan theta? What is tan theta? Root over x by a. It is root over x by a plus a into, what is theta? What is theta here? It is tan inverse root over x by a. It is tan inverse root over x by a plus c. I think you have understood it. So here you can cancel this, a gets cancels, or I is equal to, this is x tan inverse root over x by a minus a into, this is root over x by root over a. You can separate the square root, that is both in the numerator as well as denominator. You can write the square root, that is root over x by root over a plus a tan inverse root over x by a root over x by a plus c. Is that clear? Next, what will you do? This root a and a will be cancelled. That is, it goes root over a times. So final answer is I is equal to x tan inverse root over x by a minus root over ax, right, plus a tan inverse root over x upon a plus c, right. So root over a ones are root over a, and this a is divided by root over a, so it goes root over a times, right. So this is your root over ax. So the final answer is I is equal to, what is the final answer? X tan inverse root over x by a minus within square root ax plus a tan inverse within square root x by a plus c. So this is the final answer. So I think you have understood it. So this question is very, very important. You can revise it at home. I think you have understood it. This is quite simple. Okay, you can do it at home. Okay, you can revise it at home and you can do this as homework. But in this case, you have to put x is equal to a cot square theta. Sometimes in HS question paper or in HS examination, you may get this type of problem. That is, instead of sine inverse, you may get cos inverse. Now I'll give you some homework like this. Okay, you can do it at home. Okay, but these questions are not in the book. You have to do it yourself. I'll give you the hints. Okay, first of all, you copy it. So now I'll give you some problems. That is your homework, right? So this problem is your homework. I already told you about this one, isn't it? And the answer for this question will be, let us write down the answer for that part, okay? That is for integration of cos inverse root over x upon a plus x dx. You will put x is equal to a cot square theta. The answer for this question is, the answer will be, it will be x cot inverse root over x by a plus root over ax plus a cot inverse root over x upon a plus c. This will be the answer for this question. Okay, the answer for this question is this one. Is that clear? So next, write down the homework. That is, let us write it as star 1, but this is not from your book, right? So number 1 is integration of sine inverse root over x upon 1 plus x dx. Instead of a there is 1. You know, you may get the question like this. You may have 1 instead of that a. Okay, so this is sine inverse root over x upon 1 plus x. I'll give you the hints only. I'll give you the answer only. So these are your homework, right? So in this case, I'll give you the hint. You put x is equal to what? Tan square theta only. Since there is no a out here, you can put x is equal to what? Tan square theta. The answer for this part will be x tan inverse root x minus root over x plus a is 1 here, so it is tan inverse root over x plus c. The answer for this question will be this one. The hint for this question is you put x is equal to tan square theta. Okay. Next, number 2 is also your homework. So it may be cos inverse root over x upon, and instead of that a you may have 1 plus x dx. So in this case you put x is equal to cot square theta. Right, this is the hint only. So its answer will be what? The answer for this question is x cot inverse root x plus root over x plus cot inverse root over x plus c. The answer for this question is this one. This is the hint only, right? Next, number 3. So number 3 will be your integration of sine inverse root over, you may have a upon a plus x dx. So in the question that is given in the book, you had the question like this: sine inverse root over x upon a plus x. X was here, but instead of x there is a now. So a is constant out here. So what should you put for x here? You can put x is equal to a cot square theta in this case. Is that clear? And now the answer for this question will be x cot inverse root over x by a plus root over ax plus a cot inverse root over x by a plus c. Okay, the answer for this question is this one, and the hint for this question is x is equal to a cot square theta. Is that clear? And for number 4, integration of cos inverse root over a upon a plus x dx. If you have this type of question, what should you put for x? X is equal to a tan square theta. So if you put x is equal to a tan square theta, you will get the answer as x tan inverse root over x upon a minus sign root over ax plus a tan inverse, that is root over x upon a plus c. Okay, the answer for this question is this one, and the hint for this question is you put x is equal to a tan square theta. So I think you have understood it. Okay, so next, number 5. So number 5 will be your integration of sine inverse root over 1 upon 1 plus x dx. So what should you put for x out here? X is equal to, you put what? In this case you put x is equal to cot square theta only. If you put x is equal to cot square theta here, and you can use the method as you have done it in question number what? This is question number 23 from the book. So in the previous problem we did it. Okay, so x is equal to cot square theta. If you put x is equal to cot square theta, you have to differentiate it. Okay, if you put x is equal to cot square theta, 1 plus cot square theta will be cosec square theta, and 1 by cos square theta will be sin square theta. And what is square root of sin square theta? It is sin theta. Sin over sin theta is theta, but you have to differentiate it. You have to get the value for dx also. Okay, the answer for this question will be x cot inverse root x plus root x plus cot inverse root x plus c. So the answer for this question is this one, and the hint for this question is x is equal to cot square theta. And next one is number 6. Integration of cot inverse root over 1 upon 1 plus x dx. Okay, not cot, sorry, this is cos. This is your cos, right? This is integration of cos inverse. This is integration of, this is your cos, C-O-S, cos inverse, right? This is your cos inverse within square root 1 upon 1 plus x dx. If you have such type of question, you can put x is equal to tan square theta, and the answer for this question will be x tan inverse root x, then minus root x plus tan inverse root over x plus c. So the answer for this question will be this one, and the hint for this question is this one, x is equal to tan square theta. If you put x is equal to tan square theta, 1 plus tan square theta is sec square theta, 1 by sec square theta is cos square theta. What is square root of cos square theta? This is cos theta. Cos minus cos theta is theta. But you have to differentiate it and get the value for dx. Is that clear to all of you? So these are your homework. Okay. The answer for this question is this one, and the hint for this question is x is equal to, you put a cot square theta. Okay. And similarly, you can do this, all this problem at home. So you have to practice it at home. Okay. So let's do the next question. So now we'll do the next question, that is question number 39. Let's do this question now. This is integration of sine of log x dx. So this question is also very, very important, right? So now in this case, there is integration of sine of log x dx. So how can you evaluate this integration? So this is also exceptional question out here. Since this is the integration of trigonometric function only, you have to use integration by parts. So this is your sine of log x, and within trigonometric function there is logarithm function. That's why you have to use integration by parts in this case. So here sine of log x is trigonometric function actually, and one is x to the power 0, or you may take as exponential. Let us take it as exponential function. Okay. So in this case, always you take sine of log x as the first function and 1 as the second function out here. Then only you can do this integration. Okay. So I told you that this is exceptional problem out here. In this case also you have to use integration by parts, but in this case this sine of log x is taken as the first function and 1 is taken as the second function. Is that clear? In this case sine of log x is taken as the first function and 1 is taken as the second function. So let us first write I is equal to integration of, this is sine of log x dx. Okay. Now I already told you that this will be the first function now. Therefore sine of log x is taken outside, integration of dx minus integration of second bracket dy dx of first function, that is sine of log x integration of, this is dx second bracket close dx. Clear? So it is integrated by parts. Or I is equal to, let us first integrate. What is integral sine dx? X. This is sine of log x minus integration of, what is dy dx of sine of log x? First of all, it is in the form sine x. We can take log x as x, sine x form. What is the differentiation of sine x? Cos x. So it is cos of log x into, again you have to differentiate the term which is assumed as x. Log x is assumed as x. What is this differentiation? 1 upon x into, what is integral sine dx? That is your x dx. So here x gets cancels. Or I is equal to, this is your x sine of log x, right? Minus integration of, this is only cos of log x dx. It is just like your question, isn't it? Instead of sine we are getting cos. Now again, how can you evaluate this integration? That is integration of cos of log x dx. Again, you have to use integration by parts. Okay? Or I is equal to x sine of log x minus within third bracket. Again, this cos of log x is taken as the first function and 1 as the second function. So let us use integration by parts in this case also. So cos of log x is taken outside, integral sine dx minus integration of second bracket dy dx of cos of log x, integration of dx, second bracket closed dx, then third bracket is closed. So I think you have understood it. Let us simplify it now. Or I is equal to what will you write now? Or I is equal to x sine of log x, this is x sine of log x, right? It is kept as it is. Now minus sine within third bracket. Now let us first integrate. Integration of dx, x cos of log x, x cos of log x. Then there is minus sine, minus integration of. Now what is dy by dx of cos of log x? How can you differentiate it? You can take it as cos x. What is the differentiation of cos x? Minus sine x, but here it is minus sine of log x. Minus sine of log x into, again you have to differentiate the term which is assumed as x. You have to differentiate log x with respect to x again. What is the differentiation of log x? 1 upon x. Okay. Then what is integral sine dx? That is your x. Then what do we write? dx. Third bracket is closed. Now here you can cancel this xx. That is 1. So or I is equal to x sine of log x. Let us multiply by minus sign here. Minus x cos of log x, then minus into minus plus, plus into minus, minus this is integration of sine of log x dx. Again we are getting integration of sine of log x dx. Will you again integrate it by parts? No. Now you have to stop out here. So instead of integral sine of log x dx, what will you write? Here we had assumed integration of sine of log x dx as I. So instead of that integration we can write I. So or I is equal to, here x is taken common. So within second bracket this is sine of log x, right? Then minus cos of log x, second bracket is closed. So I think you have understood it. Okay. Then you have to write minus I. Instead of this integration of sine of log x dx is I. So instead of this integration you can write I. So minus I is taken to the left hand side. So it becomes 2I is equal to x within second bracket sine of log x minus cos of log x. So what is the value for I now? So now I is equal to x by 2 within second bracket. What do we write? This is sine of log x, right? Then minus cos of log x. Then second bracket is closed. So this is the answer. So in the answer you have to write plus c as a constant of integration. So this is the final answer. So I think you have understood it. This question is very, very important. You can revise it at home. So you can copy it. Now we'll do the next question. So now we'll do the next question. That is question number 24. That is integration of sine of log x divided by x cube dx. So you can take this x cube to the numerator. So it becomes, therefore I is equal to integration of x to the power minus 3. This is sine of log x dx. Now this is also integration of the product of two different functions. One is x to the power minus 3, that is your algebraic function, and the other one is sine of log x, that is trigonometric function. This is also the integration of the product of two different functions. You have to use integration by parts. Okay? And you know that according to the word Liet, among these two letters, algebraic A and trigonometric T, A comes first, isn't it? But this is exceptional problem. This is also an exceptional problem. In this case, we cannot take A as the first function and T as the second function. But in this case, we can take sine of log x as the first function and x to the power minus 3 as the second function, because there is sine of log x is there. Since there is sine of log x, this is function of the function sine of log x. Since sine of log x is also there, we can take this sine of log x as the first function and x to the power minus 3 as the second function. So this is also an exceptional problem. So in this case, we don't take x to the power minus 3 as the first function, but we take sine of log x as the first function and x to the power minus 3 as the second function. Then only you can do this integration. Okay? So let us do this integration now. I is equal to this sine of log x is taken outside, integration of x to the power minus 3 dx minus, then integration of second bracket dy dx of, this is your sine of log x, right? Then integration of x to the power minus 3 dx, second bracket closed, dx. Understood? So now next, or I is equal to, what is integration of x to the power minus 3? Let us integrate it first. What is integration of x to the power minus 3? It is just like here x to the power n dx. So x to the power n plus 1 divided by n plus 1. So it is x to the power minus 2 divided by minus 2. Then you can write sine of log x minus integration of, what is dy dx of sine of log x? So this will be cos of log x, you know that, into what is the differentiation of log x? 1 upon x, into what is integration of x to the power minus 3? X to the power minus 2 divided by minus 2. Then what do we write? Dx. So I think you have understood it. Okay. So or I is equal to, this will be this minus sign which is in the denominator. It is taken outside, minus 1 upon, it is taken to the denominator, x to the power minus 2 is taken to the denominator. So it is 2x square, then this is your sine of log x, alright. Then minus into minus plus, this is half integration of, let us simplify x to the power minus 2 upon x. When this x goes up in the numerator, it becomes x to the power minus 1. And you can simplify it with x to the power minus 2. What is x to the power minus 2 into x to the power minus 1? Powers will be added. You will get x to the power minus 3. Then what do we get? What do we write? Cos of log x dx. So I think you have understood it. Again, you have to use integration by parts in this case. X to the power minus 3 algebraic function, cos of log x is the second function, but according to the word Liet or Eilert, this algebraic function will be the first function. But in this case, this is, I already told you that this is an exceptional problem. In this case also, cos of log x is taken as the first function and x to the power minus 3 is taken as the second function. So let us use integration by parts for this function also. Or I is equal to minus 1 upon 2x square. This is your sine of log x, right? Plus half within third bracket. Let us use by parts. So here cos of log x is the first function, then integration of x to the power minus 3 dx, then minus sign, integration of second bracket dy dx of, this is your cos of log x, then integration of x to the power minus 3 dx, second bracket closed, dx, then third bracket is closed. Okay, so or I is equal to minus 1 by 2x square, This is your sine of log x, right? Plus half. Then within third bracket, what do we write? You first integrate x to the power minus 3. So its integration is x to the power minus 2 divided by minus 2, then cos of log x, right? Minus integration of, what is d by dx of cos of log x? It is just like your cos x form, minus sine of log x into 1 upon x into, what is integration of x to the power minus 3? X to the power minus 2 divided by minus 2, then what do we write? Dx. Third bracket is closed. So I think you have understood it. Okay. So let us simplify the expression within third bracket. Or I is equal to minus 1 upon 2x square minus 1 upon 2x square, then sine of log x, then you have to write sine of log x, then let us multiply it, plus into minus, minus 1/4, isn't it? 1/4 x to the power minus 3 is taken to the denominator, so it is x square. So it is 1 upon 4x square, right? Cos of log x. This is cos of log x, right? Then next, plus into minus, 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 plus, plus, then what do we write? Half into half is 1/4. It is 1/4 integration of, now what will you write here? This x is taken to the numerator. This x is taken to the numerator. If this x is taken to the numerator, it becomes x to the power minus 1. And you can simplify it with x to the power minus 2. That is x to the power minus 3. So this will be x to the power minus 3. Then sine of log x dx. Then this is sine of log x dx. So I think you have understood it. Again, will you integrate it by parts? No, don't use integration by parts now. So instead of that integration, you can write I, because what is the integration of x to the power minus 3 sine of log x dx? It is I. So here you can write I there. Or I is equal to, now here you can take the LCM. What's the LCM here? 2x square, 4x square. So here 4x square is the LCM. So in the numerator we have 4x square is divided by 2x square, so it is 2, right? Minus 2 sine of log x. It is minus 2 sine of log x, then minus cos of log x. Minus cos of log x. Now this 4x square is divided by 4x square, that is 1. So it is minus cos of log x plus 1/4 into, this is your I. That is integration of x to the power minus 3 sine of log x dx. You can write it as I. So I think you have understood it. So this is minus, sorry. Plus into minus, minus, minus into minus, plus, plus into minus, minus. So this will be minus sign, right? Sorry, this one is wrong out here. You have to multiply it by minus here, plus here, plus into minus, minus, minus into minus, plus, plus into minus, minus, right? So it is half into half is 1/4. X is taken to the numerator, it becomes x to the power minus 1, and it is simplified with x to the power minus 2, and you have to write x to the power minus 3, then sine of log x dx, because there is sine of log x. So instead of integration of x to the power minus 3 sine of log x dx is I. So this is your minus sign, right? So I think you have understood it. Okay. So or, now next what will you do? This minus 1/4 I is taken to the left hand side. So I plus 1/4 I is equal to, your minus is taken common. So within second bracket we have 2 sine of log x. 2 sine of log x, minus to minus plus. This is cos of log x. This is cos of log x. This whole divided by, this is your 4x square. So now let us simplify it. Let us simplify it again. Now you can add these I. 4i plus I is 5i divided by 4 is equal to minus, within second bracket it is 2 sine of log x plus cos of log x. Here second bracket is closed, whole divided by, this is your 4x squared. So here you can cancel this, 4 will be cancelled. Or what is the value for I? You can take this 5 to the right hand side. So when this 5 is taken to the right hand side, you should write it in the denominator. That is minus, within second bracket 2 sine of log x plus cos of log x. Second bracket is closed, whole divided by. So it is cross multiplied by 5 here. So it is 5x square. Okay, now we have finished integration. So in the answer you have to write plus c. So this is the final answer. So I think you have understood it. So this question is also very important. You can mark it. So I think you have understood it. So you can copy it. Now let's do the next question now. So now we'll do the next question, that is question number 37. The question is integral of, within second bracket, sine of log x plus cos of log x second bracket close dx. Now both sine of log x and cos of log x is there. And you know that if you take this log x as x, this will be sine x plus cos x. And you know that integration of sine x is cos x. Okay? Since the differentiation of the first function is the second function, you have to use integration by parts for the first function only, and the second function you have to keep it as it is. Don't use integration by parts for the second function. So let us do this problem now. So first of all, let us write I is equal to integration of, this is sine of log x plus cos of log x. Both are within second bracket. Then what do we write? Dx there. Okay. So let us first separate them. I is equal to integration of sine of log x dx plus integration of cos of log x dx. So I already told you the method. Let us take this log x as x, this is sine x and this is cos x. And you know that differentiation of sine x is cos x. That is, differentiation of the first function is the second function. So you have to use integration by parts for the first function only, keeping the second function as it is. That is, don't use integration by parts for this second function. Only you have to use integration by parts for the first function only. Okay. So, or I is equal to, this is the first function in this case. This is exceptional problem, I told you, isn't it? So sine of log x, then integration of dx minus integration of second bracket dy dx of, this is your sine of log x, then integration of dx second bracket close dx. So this is integration by parts for the first function only, and the second function is kept as it is. That is integration of, this is cos of log x dx. Understood? So next, or I is equal to, what is integral sine dx? That is your x, and this is sine of log x, right? Minus integration of, what is dy dx of sine of log x? You know that this is cos of log x into, again differentiate log x with respect to x, 1 by x, into what is integral sine dx, that is your x dx, then plus this integration is kept as it is, so it is cos of log x dx. Understood? So now we can cancel this x, cancel them. Or I is equal to x sine of log x, okay, then minus integration of, this is your cos of log x dx, and then plus integration of, this is your cos of log x dx. Now you can cancel these two terms, cancel it. So what is the value for I now? So or now this is I is equal to, what is the answer? It is only x sine of log x. X sine of log x, then what do you write? Plus c. So this is the final answer. So this question is also important. You can mark it. So you can copy it. Now we'll do the next question. So now you have to evaluate this integration. That is question number 38. Integral sign within bracket e to the power log x plus second term is sin x bracket close and outside bracket there is cos x dx. So let us evaluate this integration. So therefore I is equal to integration of within bracket e to the power log x plus sin x bracket closed, then you can write cos x dx. Okay, so now in this case, first of all you have to simplify the given expression. So I already told you about e to the power log x. If there is no base for log x, you can write base as e, which is equal to e to the power log x base e is x. Okay, now here you can write I is equal to integration of within bracket e to the power log x means x plus sin x bracket closed cos x dx, right? So or I is equal, let us multiply it and separate integral sign and dx also. Let us multiply cos x by x plus sin x and then you can separate integral sign and dx also. So it is integration of x, it is integration of x cos x dx plus integration of, this is your sin x cos x dx. Okay, so now for this first function you can use integration by parts. X is algebraic function and cos x is trigonometric function. So algebraic function is a, trigonometric function is t. So among these two letters a and t, which letter comes first in the word let or islet? A comes first. That means x is the first function and cos x is the second function. So let us use by parts here. I is equal to x integration of cos x dx minus integration of second bracket, this is dy dx of x integration of cos x dx second bracket close dx. Now this function is integrated by parts. Now what will you do with this second function? That is, there is integration of sin x cos x dx. Whenever you have sin x cos x, you have to multiply and divide by 2 so that we can use this formula. That is 2 sin x cos x is equal to, you know that this is sin 2x, right? 2 sin x cos x is sin 2x. But in this case there is no 2 out here. You have to multiply it by 2 and should be cancelled. So it should be multiplied and divided by 2. That means you can write plus half integration of, this is your 2 sin x cos x dx. So I think you have understood it. Okay, or I is equal to x into, what is integration of cos x? Differentiation of which function is cos x? This is your sin x minus integration of dy dx of x is 1. You know that dy dx of x is 1. You don't have to write it. Integration of cos x is sin x dx, right? Plus half, this is integration of, what is 2 sin x cos x? It is sin 2x dx. Integration of 2 sin x cos x dx is sin 2x. Okay, so or I is equal to, now this is I is equal to x sin x is kept as it is, x sin x minus, what is integration of sin x? That means differentiation of which function is sin x? Minus cos x. So this is your minus cos x, right? Then plus half. Then there is plus half into, what is integration of sin 2x? That is differentiation of which function is sine 2x? That is minus cos 2x divided by 2. Then what do we write? Plus c. Okay. So let us simplify it. Or I is equal to, this is x sine x, minus into minus plus, this is your cos x, plus into minus minus, this is your 1/4. Then what do you write? Cos 2x plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now this much is for today. So we did some problem today. I think we did 4 or 5 problems. So you revise all the problems that we did today, and you also do the homework I had given you, and you revise all the problems that we did in this chapter, integration by parts. So this much is for today, and in the next online class we'll do more problems on this integration by parts.